In this video, we will solve MDCAT past paper. Question 1 says that a body is moving with an initial velocity of 2 km per second. After a time of 50 seconds, its velocity becomes 1.5 km per second. Its acceleration will be, in the question, we have the initial velocity which is 2 km per second, which means that it is equal to 2000 meters. Then we have the final velocity which is equal to 1500 meters. And we also have the time period which is 50 seconds. We know that the formula of acceleration is equal to Vf minus Vi divided by t. Now we will just put the values which are 1500 minus 2000 divided by 50, which is equal to minus 500 divided by 50, and it is equal to 10 meters per second. Here we will ignore the minus sign as acceleration can never be minus. Therefore, option D is the correct answer. Question 2 says that when two bodies stick together after collision, the collision is said to be when two bodies stick together. The final kinetic energy is equal to 0. But initially there was some kinetic energy which could be any number which is x. Now we can say that when bodies stick together, then all the kinetic energy is lost. We can write it as kinetic energy initial is not equal to kinetic energy final. Hence, we can say that the collision is perfectly inelastic. Therefore, we can say that the collision is completely inelastic. Hence, option B is the correct answer. Question 3 says that an object of 0.5 kg mass has a momentum of 10 kg meter per second. Then the kinetic energy of the object will be. In the question, we have the momentum which is 10 kg meter per second, and we have the mass which is 0.5 kg. We know that the formula of kinetic energy is equal to momentum square divided by 2 into mass. Now we will put the values which will be 10 square divided by 2 into 0.5. After solving it, we will get 100 joule, which is option A. Question 4 says that with same initial velocity, a body is thrown at angle 15 degree, 30 degree, 45 degree and 60 degree, at which two angle ranges are in the ratio 1:2. As we know that the range is directly proportional to sine 2 theta. The ratio of angles should be R1 divided by R2, which is equal to sine 2 theta 1 divided by sine 2 theta 2. Now in this equation we will put all of these values one by one. When we will put 75 and 45, we will get 1 divided by 2 divided by 1, which is equal to 1 over 2. Hence, two angle ranges are in ratio 1 by 2 are 75 degree and 45 degree, which is option C. Question 5 says that two bodies are moving in opposite direction with velocity v. The magnitude of their relative velocity is. Now, if two bodies have velocity v1 which is equal to v and v2 which is equal to v, the relative velocity will be equal to v1 plus v2 which is equal to v plus v, and the answer is 2v. Hence, option B is the correct answer. Question 6 says that a 1000 kg car and a 2000 kg car are lifted to the same height at a constant speed in auto service station. Lifting the more massive car requires dash work. We know that the formula of weight is equal to mgh. From this formula, we can say that weight is directly proportional to the mass. Now, we know that there are two cars, a 1000 kg car and a 2000 kg car are lifted to the same height. Now, we know that the weight is twice. Therefore, we can say that lifting the more massive car requires twice as much work, which is option C. Question 7 says that a 6 kg block is released from the rest 80 meter above the ground. When it has fallen, its 60 meter kinetic energy is approximately From the question, we have its mass, which is 6 kg. We have its initial height, which is 80 meters, and we have its final height, which is 60 meters. Now we know that as the body is falling, the acceleration due to gravity will be 9.8 meters per second. Hence, the total kinetic energy will be mgh2 minus mgh1. After putting values and solving it, we will get 1200 joules, which is option C. Question 8 says that an object at rest may have the options are speed, acceleration, velocity, and energy. Now, when an object is at rest, it cannot have any speed as the object is stationary, nor it has an acceleration nor velocity. At last, we have energy. We know that potential energy does not require any motion. Therefore, we can say that an object at rest may have energy, which is option D. Question 9 says that which of the following example shows an object that does not change its magnitude of velocity but only its direction of motion? The options are parachute bailing out of an airplane, a body moving up against gravity, uniform motion of a body along a circular path, or car moving with uniform velocity in straight line. We know that when a parachute is bailing out of an airplane, the direction is also changed and the magnitude of velocity is also changing. And when a body is moving up against the gravity, it changes the magnitude of the velocity but direction does not change. And if we talk about car moving with uniform velocity in straight line, we can clearly see that the direction is not changed. Hence, at last, we have the option C, which is uniform motion of a body along a circular path. We know that in a circular motion, direction is continuously changing. Hence, option C is the correct answer. Question 10 says that power due to centripetal force for circular motion will be. We know that the formula of power is equal to Fv cos theta. Now, when a body is moving in circular path, we know that at every angle the theta is 90 degrees. Therefore, when we will put Fv cos 90, we will get 0. Hence, option A is the correct answer. Question 11 says that the angular velocity of the or and of a clock is. We know that an or and completes its one revolution in 12 hours. So we can say that the time period is 12. Now we know that the angular frequency can be measured by the formula which is 2 pi divided by t. Here t is 12. So by putting values we will get pi over 6 radian per hour. Hence option B is the correct answer. Question 12 says that the direction of angular acceleration is along axis of rotation, along tangent towards center of the circle, or away from the center of the circle. We know that the angular acceleration is related to axial vectors. Therefore, we can say that it is along the axis of rotation. Hence, option A is the correct answer. Question 13 says that a simple harmonic oscillator has a frequency of 0.5 Hz. Which equation relates its acceleration and displacement x? The angular frequency can be measured by the formula which is 2 pi f. And in the question we have the frequency which is 0.5. By putting values we will get 2 pi into 0.5 which is equal to pi. Hence we can say that the angular frequency is pi. Now we know that the formula of acceleration is minus x omega square. Here omega is equal to pi, hence we can write it as pi square x. Hence the correct answer is option D. Question 14 says that if time period of simple harmonic oscillator is 2 seconds, then time required between mean to extreme is. We know that the time required between mean to extreme will be t over 4. Here the time period is 2 seconds. Hence we can write it as 2 divided by 4 which is equal to 0.5 seconds. Hence option C is the correct answer. Question 15 says that minimum length of both ends open pipe that resonates with frequency of 175 Hz if velocity is 350 meter per second is. We know that in an open pipe, the frequency is equal to NV over 2L. From this, we will solve for the length, which will be NV over 2F. Here, N is equal to 1, frequency is 175 Hz, velocity is 350. By putting values in the equation, we will get 1 into 350 divided by 2 into 175, which is equal to 350 divided by 350, and the length will be 1 meter, which is option A. Hence, option A is the correct answer. Question 16 says that the product of angular frequency and time period is. We know that angular frequency is equal to 2 pi t. We want the product of angular frequency and the time period. So we will move this time period to this side of the equation and we will get omega t, which is the product of angular frequency and time period, and it is equal to 2 pi. Hence, option A is the correct answer. Question 17 says that speed of sound is least in. We know that the phase of matter has a large impact upon the elastic properties of a medium. So we can say that the bond strength between particles is strongest in solid and weakest in the gaseous state. Or we can say that the speed of sound is highest in solid, then in liquid, and then in gas. So from this we can say that the speed of sound is least in gas. Therefore, option C is the correct answer. Question 18 says that speed of sound in gas is independent of the temperature, density, and humidity may affect the speed of sound, but the pressure of the gas has no effect on the speed of the sound. Hence, we can say that the speed of the sound in gas is independent of pressure, which is option A. Question 19 says that a sound source is moving towards a stationary observer with 1/5 of the speed of the sound. The ratio of real to apparent frequency is. According to Doppler's effect, we know that apparent frequency is equal to V minus V naught divided by V minus Vs into F. Here, F bar is apparent frequency, F is the actual frequency, V is the actual velocity, V naught is the velocity of the observer, and Vs is the velocity of the source. We know that V naught is equal to 0, so we can write it as V minus V naught is equal to V. Hence, this is our apparent frequency. And according to the question, we have the stationary observer with 1/5 of the speed of sound. Hence, we can say that the velocity of the source will be 4 over 5. By putting this in this formula, we will get F bar is equal to V over V minus 4 by 5 into F. Now, as we have to find the ratio of real to apparent frequency, we can solve it by this, and from here we can say that it is equal to V over 4V divided by 5. By simplifying it, we will get 4 over 5, which is option A. Hence, option A is the correct answer. Question 20 says that Doppler effect is independent of the velocity of source, distance between source and observer, velocity of listener, none of the above. Now we know that according to Doppler's effect, F bar is equal to V minus V naught divided by V minus Vs into F. Now talking about the velocity of the source, we have the velocity of the source. Hence, it is not independent of velocity of the source. Talking about the velocity of the listener, which is the velocity of the observer, hence it is also not independent of velocity of listener. At last, we have the distance between source and observer. In this formula here, we don't see the distance between source and observer. Therefore, we can say that Doppler effect is independent of distance between source and observer. Hence, option B is the correct answer. Question 21 says that certain force acting on a 4 kg mass changes its velocity from 10 meter per second to 8 meter per second. Calculate the work done by the force. We know that the formula of work done is equal to 1 over 2 m Vf square minus Vi square. In the question, we have the mass which is 4 kg. Then we have the initial velocity which is 10 meters per second and the final velocity which is 8 meter per second. By putting values, we will get work done is equal to 1 over 2 4 into 8 square minus 10 square. By simplifying it and solving it, we will get minus 72 joule. Hence, option D is the correct answer. Question 22 says that work done by the gravitational force on a body of mass m moving on a smooth horizontal surface through a distance s is given acceleration due to gravity is g. We know that the formula of work done is equal to Fd cos theta. Now we know that the gravitational force is perpendicular to the distance moved by the body, which is s. So the work done becomes Fd cos 90, which is equal to 0. Hence option B is the correct answer. Question 23 says that work is said to be done if force and displacement are parallel to each other, inclined at an angle with each other except 90 or 270 degrees, anti-parallel to each other. We know that the work is said to be done when the force and displacement occurs, irrespective to when they are at 90 degrees and 270 degrees. Hence, we can say that option D is the correct answer which says all of these. Question 24 says that from an automatic gun, a man fires 180 bullets per minute with a speed of 360 km per hour. If each bullet weighs 10 grams, then the power of the gun is. According to the question, we have the velocity which is 360 km per hour. We have the mass which is 10 grams. Then we have the time period which is 180 bullets per minute. We know that the formula of power is equal to kinetic energy divided by the time taken. We know that the kinetic energy is equal to 1 over 2 mv squared divided by t. We will multiply it by n and we know that n is equal to 1. By putting values and solving it, we will get 150 joule, which is option A. Question 25 says that which relation exactly describes the isothermal process? We know that in an isothermal process, del U is equal to 0. We know that the formula of heat energy is equal to Q is equal to del U plus W. As del U is 0, we can write it as Q is equal to W. Hence, option A is the correct answer. Question 26 says that in an adiabatic process, 95 joule work is done on a gas. The change in internal energy of gas is. We know that in adiabatic compression, the work done is negative and the del U is 0. Hence, we can write it as Q is equal to minus W. Here, the work done is 95 joule. As it is an adiabatic process, the work done will be negative. Hence, we can write it as W is equal to minus 95. By putting values, we will get minus into minus 95, which is equal to 95 joule. Hence, option B is the correct answer. Question 27 says that in a thermodynamic process, the pressure of gas is changed in such manner that the gas released 35 joule of heat and 25 joule of work was done on the gas. If the initial internal energy of the gas was 20 joule, then the final internal energy will be. We know that Q is equal to del U plus W. And here we can say that del U is equal to UF minus UI. So we can write it as Q is equal to UF minus UI plus W. In the question, we have the heat which is 35 joule. Then we have the work done which is 25 joule. And the initial internal energy is 20 joule. And we have to find the final internal energy. By putting values, we will get 35 is equal to UF minus 20 minus 25. Here we will have a minus sign as the gas is being released. By solving it, we will get 10 joule. Hence, option C is the correct answer. Question 28 says that a parallel plate capacitor has 6 volt between plates separated by 3 microns. Find electric field between the plates. According to the question, we have the potential difference as 6 volts and we have the distance which is equal to 3 microns. We know that 1 micron is equal to millimeters, so we can write it as 3 millimeters. Now we can also write it as 3 into 10 raised to the power of minus 6 meters. So we know that the formula of electric field is equal to E is equal to V divided by D. By putting values, we will get 6 divided by 3 into 10 raised to the power of minus 6, which is equal to 2 into 10 raised to the power of 6 volt per meter, which is option C. Hence, option C is the correct answer. Question 29 says that if charges become half and distance between them is doubled, then the new force will be. According to Coulomb's law, force is equal to K Q1 into Q2 divided by R square. According to the question, if the charges are half, so we can write it as Q1 divided by 2 and Q2 will be Q2 divided by 2. And the distance between them is doubled. Hence, we can write it as R is equal to 2R. Now, we will put these values in this formula and we will get the new force as F bar is equal to K Q1 divided by 2 into Q2 divided by 2 divided by 2R whole square. By solving it, we will get K Q1 Q2 divided by 4 divided by 4R square. By simplifying it, we will get K Q1 Q2 divided by 16R square. We can write this part as 1 over 16 into K Q1 Q2 divided by R square. As this part resembles this part, so we can write it as the new force is equal to previous force divided by 16. Hence, we can say that option A is the correct answer.